Hi, I'm Herb Roy, a Technical Sales Manager at Micro Measurements. In this video, I'm going to show you how to solder lead wire and apply M-Code A protective coating to a CEA strain gauge bonded to a metal beam. Following successful surface preparation and bonding operations, you will want to solder lead wires to the gauge. This will allow you to connect it to a strain gauge instrument. We will then follow with an appropriate coating to protect your installation from the testing environment. I will proceed with these following steps. Prepare the lead wire by thermally stripping, twisting, and tinning. Tin the copper CEA strain gauge tabs and trim the leads. Position the lead wire for soldering to the tabs. Solder the lead wire to the tabs. Clean around the solder connection to remove all flux residue. Provide strain relief for the lead wire. And finally, apply protective coating. The materials I will use are the following: a strain gauge bonded to an aluminum beam, a length of 26 gauge 3-conductor vinyl insulated wire, 361A 20R rosin core solder, a thermal stripper, a temperature controlled soldering station, gauze sponge and PDT-1 drafting tape, M-Code A protective coating, rosin solvent, scissors, wire cutters, tweezers, and a dental probe. First, I will prepare and tin the 3-conductor length of lead wire by stripping, twisting, and tinning. I will use a dental probe to help separate the strands of wire. To better understand the benefits of a 3-lead wire connection to a single strain gauge, see Tech Tip TT612, the 3-wire quarter bridge circuit, in the technical area of our website. Using your chosen length of 3-conductor lead wire, we will first thermally strip about 3/4 inch of the insulation from both ends of the wire. Thermal stripping minimizes nicking of wires that may cause breaking of your lead wire, leading to resistance shifts during a test. Working with the gauge end of the lead wire first, we will create 2 bundles by separating the strands of the red bundle from the white and black bundles. Twist the red bundle tightly back to the insulation. Then twist the white and black bundles together tightly back to the insulation. I'll prepare the instrument end of the lead wire in a similar way. This time I will create 3 separate bundles, one of each color. Tin all 5 twisted bundles by placing your properly set temperature-controlled iron on the table surface. Use a setting at the top of the 361 band, which is about 600 degrees Fahrenheit tip temperature. Clean the tip with gauze. Reflow rosin core solder to create a small puddle at the tip. Place the bundle in the puddle and add more solder while drawing the wire through the puddle. Tin all the way back to the insulation. Using wire cutters, make a small split about 1/4 inch between the red and white insulation at the gauge end. This will help to align the bundles with the tabs and ensure that there is not a connection between the red and white wires. At the instrument end of the lead wire, make a small split between each bundle. Split the wire back about 2 inches or so. This will allow an easier connection to the strain gauge instrument. Next, I will tin the gauge tabs and prepare the lead wire to solder to the tabs. Clean the iron tip on a gauze sponge and add fresh solder. Now we will tin the gauge tab. Set the rosin core solder on the tab, apply firm pressure with the tin soldering iron tip, and add more solder for about a second. Place the tin gauge end wire bundles over the tin tab to determine how much to trim the wire bundles. Make sure that when soldered in place, the wire insulation will rest on the backing of the gauge below the tabs. Trim the tinned bundles and recheck the size. Apply a 1.5 inch length of drafting tape right up to the end of the insulation. Bend the wire in a cobra head shape to create spring tension when the wire is taped in place. Tape the wire bundles over the tin tabs. After taping, realign the bundles over the tabs if necessary. Now we will solder the wires to the tabs. With a freshly tinned soldering iron, place the rosin core solder on the tab. Apply firm pressure, adding a small amount of solder for about a second. Finally, I will clean the installation to remove all traces of rosin flux, create a strain relief loop in the wire, and apply protective coating. Clean the gauge and wire using rosin solvent to bring the rosin flux in suspension. Use the rosin solvent to free the tape from the surface of the beam. Soak the solvent up with a gauze sponge. Repeat this step about 3 times until all flux residue is removed. Create a strain relief loop using a small tool like a dental probe and tweezers. Apply drafting tape behind the loop. Place another piece of tape well above the top of the gauge to limit the flow of the protective coating. Brush the coating over the gauge and soldered connections. Allow the coating to air dry at least 20 minutes. Then remove the tape above the gauge. This completes the soldering and coating operation. An explanation of strain gauge soldering techniques can be found in Tech Tip TT609 in the technical literature area of our website. More information about protective coatings can be found in the installation accessories area of our website.